Good evening, everyone. My name is Captain Nitish Pawar. I'm going to teach you aviation meteorology. Now, for this is the trial class, so we are going to, as per the syllabus, the first chapter, the atmosphere. So, the first question arise in your brain would be why we are studying aviation meteorology and what it is basically meaning of meteorology. So, its meaning is that you are studying about the atmosphere in the simplest term. So why we need to study about atmosphere? Because as in pilot, as you fly the aircraft, you are continuously surrounded by the atmosphere, and this atmosphere will result into various different phenomena on aircraft performance. For example, if it is higher, your aircraft performance is also higher, and if it is low, it is aircraft performance is also low. So also there are cloud formation, there are thunderstorm which might you not want to go into. So if you know weather patterns, if you can study that, and if you know you can predict the weather, it will be very safe flying, correct? So continuously we need to monitor our atmosphere. So the atmosphere can be called as homogeneous mixture of gases, and which we also call as gas, air. So the atmosphere is the homogeneous mixture of gases called air. Okay, this is attached to earth due to the gravitational force, correct? This is surrounded by the jacket of homogeneous gases of mixture, and this is attached to the earth due to the presence of gravitational force. Now there is no fixed limit of how long is your atmosphere, because as you go higher and higher it start to get thin, but scientists assume that it is roughly approximately 480 kilometer thick. Beyond that also it can uh, exist, but that is irrelevant to us. Okay, and since 480 kilometers is quite high, but the majority of the atmosphere are present in 16 kilometer of the height. So what this homogeneous mixture of air or homogeneous mixture of gases are made of? So from the childhood, from the class first, you have studied that this is the, so most of the air are nitrogen, is nitrogen. So nitrogen holds about 78%, and 21% is oxygen. Apart from that, we also got some trace molecules. So trace molecules or trace gases are argon, neon, hydrogen, carbon dioxide, nitrogen oxide, CO2, so on. Okay, so this is composition of air, and as you can see, the maximum of air is made of nitrogen, that is 78, to be precise 78.09%, and oxygen hold up to be 20.95%. The remaining gases are argon, CO2, which hold the maximum in this. Then we got another trace gases as neon, hydrogen. So argon holds up to 0.93% and CO2 holds 0.035%. The remaining trace gases are neon, hydrogen, carbon dioxide, neon, hydrogen, CO2, SO, nitrogen dioxide. Okay, and carbon monoxide, etc. And one of the important trace gases is your water vapor. So from this, there is one favorite question for DGCM. They ask quite often that what is the percentage of nitrogen is to oxygen. So basically they are asking about the ratio. Now the ratio is defined in two terms, one by volume and second by weight. So by volume, nitrogen is to oxygen is 4 is to 1, and by weight, nitrogen is to oxygen is 3 is to 1. So a lot of times students get confused, and by volume they write 3 is to 1. But remember, by volume, it is nitrogen 4 share and oxygen 1 share. Okay, so it is 4 is to 1. And by weight, it is 3:1. Okay. Another important point to remember this, I was telling you guys, as you go higher and higher, your density of the molecule or the molecules start to vanish, okay, or get to start thinning, okay, of the molecules, because maximum gravity you can find at the earth. As you go higher and higher, the atmosphere, maximum atmosphere is settled down to the earth. And we have studied that 80% of the atmosphere we find within 16 kilometer of the height, correct? So what happened after 10,000 feet, we require additional supplementary oxygen, okay? So either you have to have pressurized aircraft, or you have to take oxygen mask with you, so we can fly beyond 10,000 kilometer, okay, correction, 10,000 feet. Beyond 10,000 feet you need oxygen mask, or you have to pressurize chamber, just like in Airbus A320. All the modern airliners nowadays have a pressurized cabin, okay, because they are operating from flight level 290 to flight level 410. This is roughly 29,000 feet to 41,000 feet of the height. It is optimum level for airliners to operate, to save fuel, and to avoid the weather and all that. So you get supplementary oxygen is needed above 10,000 feet, okay, and above only pressurized aircraft like 320 can fly. I'm writing the example of 320, but you can take any example. For example, if you want to take 737, or it's your 777 is your favorite aircraft, but they are pressurized. The training aircraft such as Cessna 172 and Cessna 152, they are what? They are unpressurized. Okay. So that they can fly up to 14 to 15,000 feet of the height, according to their POH and different model of the aircraft. But still, after 10,000 feet, so you cannot go without a oxygen supply. Okay. The another important point in atmosphere is that up to 80 kilometers of the height, it is called as homosphere. Okay, the first definition we have studied that it is a homogeneous mixture of gases. Now this homogeneous mixture of gases is eventually thoroughly mixed out, okay, in the atmosphere, and above 80 kilometer it is not properly mixed, you can say that. Okay, so up to 80 kilometer of height is called as homosphere, okay, and beyond 80 kilometer it is called as heterosphere. So these are the two terms, remember this, and you're good. Homogeneous, homosphere and heterosphere. Okay, so up to 80 kilometer it is eventually good mixing, okay, and you're ready available. The next point is your greenhouse effect. Okay, so is it a bad thing? Not necessarily, because if we study the evolution and if we see the creation of the earth, so start from the Big Bang theory, at that time it was a hot air mass, start to cool down, okay, and start to release the gases. These gases were greenhouse gases. So initially, if these greenhouse gases were not there, our planet could be a cold desert, okay, which is highly unsuitable for any living organism to live. This because of these greenhouse gases, this atmosphere warmed up, that became suitable for all the living organisms to grow. But the mean why this is defamed, or why this is called as a bad thing, because we are releasing these gases, greenhouse gases, in excessive quantity, which is increasing the temperature rapidly. Okay, so initially which was keeping the temperature in a constant or in a good manner, now is increasing rapidly. Okay, so what are these greenhouse gases? Okay, we got greenhouse gases like methane, sulfur dioxide, nitrogen dioxide, ozone, and water vapor. So water vapor plays a very important role, as it does not only uh, create your weather patterns. It also be responsible for the heating of the earth. Okay, what happened in the greenhouse effect? Basically, your short wavelength of a sunlight are coming, okay, in the atmosphere. This atmosphere reflect back and trapping your long wave of radiation. So long wave of radiation is trapped in the earth atmosphere, okay, resulting in the heating effect. This heating effect is called a greenhouse effect. Okay, so what are the key gases responsible for this thing, greenhouse effect? We can call it as methane, sulfur dioxide, nitrogen dioxide, ozone, and water vapor. So these are the key gases responsible for the heating of your weather. Okay. So as we discussed that your long wave radiation are trapped due to the gases. Okay. Now there is one term called as dry air or saturated air. Okay. What is meaning of dry air and saturated air? Dry means it doesn't have any moisture, correct? Yes, that's it. In simplest term, you can say that the dry air is without the moisture, but it has some trace moisture present. I'll discuss that in brief. So next term is dry air and saturated air. What do you understand by saturation of air? We know that water vapor are always present in our atmosphere, correct? And that percentage is 4% by volume. So this is the maximum air molecule. Say example, a square box. Take a molecule of square box as your water air molecule. Okay, this air molecule have lot of different type of particles. Okay, this any gases, nitrogen, oxygen, all that, but it also has some trace amount of your water molecule. This water, say for 4 molecule, if there are 100 molecules, there are 4%. 4 molecule of water vapor can exist. Beyond that, it won't be able to hold. Okay, it will start raining after 4%. If the relative humidity is high and the remaining condition suits it, either it will turn into cloud or it will start raining. Okay, so a water vapor, okay, or you can say a air molecule can hold maximum of a parcel of air can maximum hold of 4% water vapor by volume. Okay, so maximum of 4% of water vapor by volume. And when the 4% of water vapor, when the 4% of water vapor by volume is achieved, we call its relative humidity is 100%. Okay, for example, 3% is achieved, that is 75%. 2% is 50%, and so on. So relative humidity is 100% means the maximum saturation has been achieved. That time, that air parcel is called as saturated air. 4% of water vapor by volume, and it is referred as relative humidity is 100%. Okay, and termed as saturated air. Whenever the relative humidity is less than 100%, it is called as unsaturated air, or also called as dry air. Okay, so it is not that it doesn't have any water moisture. It has some less amount of water moisture, but it is not 100%. Okay, so relative humidity, if it is less than 100%, it is called as unsaturated air or dry air. Your warmer air can hold greater amount of water vapor. As you increase the temperature of air molecule, what happens? This parcel start to expand. If it is expanding, you can say this molecule size will be increased. Okay, to remember that. So if the size is increased, it will hold maximum water vapor. Okay. So warmer air can hold a greater amount of water vapor. Okay. Now the density of saturated air will be always less than your density of dry air. Why? Remember something like that, your water vapor is bigger molecule. Okay. This bigger molecule will take a lot of space. Molecule. Okay. And it will have hollow spaces in that. So whenever there is a saturated air present, this hollow space give you lesser density. You can remember like that. So density of saturated air is always less than the density of dry air. Density of saturated air is always less than the density of dry air. Okay. Not talking about your ozone layer, which is very important if we are studying about the atmosphere, because it is one of the key responsible factor for maintaining your homogeneous atmosphere. Correct. So your ozone, we can find it somewhere approximately 10 to 50 kilometer. Okay, this ozone molecule, and the maximum concentrated ozone layer, we call it as, is concentrated around 20 to 25 kilometer of the height. Okay, so we can find the maximum concentration around 20 to 25 kilometers. If we are talking about your ozone layer, then what about your ozone layer depletion? Definitely, we have heard that uh, your gases like CNC and all other things are responsible for your depletion of ozone layer, which is creating the hole. Also, ozone layer is one. Uh, your ozone layer will do one more important thing. That is blocking of your harmful UV rays, because UV rays are such an intensity thing that it can burn the things. Okay, it can cause cancer to humans as well. So your atmosphere are suitable for living is also because of your ozone layer, because maximum of ozone layer will absorb the harmful UVA and UVB type of ray. Okay, so remember that your ozone is keeping you alive. So be thankful you're living in a such a great atmosphere. The next important point to remember in this is the vertical distribution of air mass. So there is small column you can remember that a vertical distribution of air mass is how it's done. For example, up to 6 kilometer, you can find half of the entire air mass. Okay, up to 6 kilometer, you can find almost half of the entire vertical air mass. So what is the vertical distribution? So how is the vertical distribution? Up to 6 kilometer, you'll find half of the entire vertical air mass. Okay, up to 10 kilometer, you'll find third or fourth of your entire vertical air mass, and up to 35 kilometer, you'll find out 99% of your entire air mass. Okay, so what happen as you go higher and higher? The first important thing fall is your temperature, and your temperature is falling. Also, your density is also falling. Okay, even though temperature is inversely proportional to density, but as your molecule is becoming thin, okay, number of molecules is reducing, so your density is falling, and so is your temperature. Okay, so temperature fall up to a particular height. So temperature falls with height. Okay, and the atmosphere, that means what? The atmosphere above is not hot. Your atmosphere is heating from the ground above. Okay, so the atmosphere is heated from below and not above. Okay, The next point in this to remember is your sensible heat and latent heat. So 20%, 23% the responsible for your heating of the atmosphere is because of sensible heating. What is meaning of sensible heat? It has conduction, convection and radiation. So these three parameters contribute to 23% of your total heat. The remaining heat is your latent heat. Latent heat is in which you got your evaporation, condensation and sublimation. That is responsible for 77% of your total heat. So your sensible heat got your conduction, convection, radiation, that is responsible for your 23%. Okay, and your latent heat, what you got in that? Evaporation, condensation and sublimation. It is for 77%. Okay, so we will discuss about now the atmosphere is divided into layerings. Okay, based on the characteristic of that layering, we got troposphere, stratosphere, mesosphere, thermosphere and exosphere. Okay, this layering, okay, so your initial troposphere is roughly around 0 to 14 or 18 kilometer of height depending on polar. On polar region your troposphere is roughly 10 kilometer. So on over here it is 10 kilometer, and on this side, so it could be approximately 14 or 18 kilometer of height, 14 to 18. Okay, this is the important things. Rest of the things, so most of the flying will occur in your troposphere region. After that you got your stratosphere. In stratosphere you got uh, what your ozone layer, and you'll experience gravity in this region. Okay, and one of the key phenomena known as mother of the pearl cloud. Okay, so it's one type of cloud which has pinkish appearance in that thing. So you can find that in this region, mother of pearl clouds. Okay, mother of the pearl cloud, can you find that here? Okay, this is extended from 12 to 50 kilometer of the height, and as you go higher you got mesosphere. Now this mesosphere is going to 50 to 80 kilometer high. Okay, some cloud such as noctilucent cloud are present in this region. Okay, and as you go higher we got thermosphere in which you got your rockets, satellites. Okay, this extend from 80 to 700 kilometer, and beyond that we assume it to be a exosphere. Okay, beyond that we doesn't measure, actually it doesn't affect that. Okay, now your apart from that we have one more classification known as ionosphere. Okay, up to which there is a presence of ionosphere, and the ionosphere layer is about 60 kilometer. Okay, so ionosphere is about, okay, so we got different layering. Eventually we will study that in navigation topic, that you got different type of layer in that ionosphere. We got D, E, F1 and F2. Okay, so we generally use ionosphere as a source of reflecting of your radio wave. Okay, so your sky wave goes in that ionosphere region, reflect back due to the total internal reflection. Okay, and it came back to the atmosphere. So we, okay, I was talking you earlier that over the polar region, generally tropopause is present at 8 to 10 kilometers of height, and in the equator, it is for 16 to 18 kilometers high. So why is that? This is because of the presence of temperature difference. You can say that colder region have higher density. Okay, this diagram will give you a rough idea. Okay, this region will have a colder. So I'm not drawing this with say a red, green, blue line. Okay, so just a second. So this is the colder region. So in colder region, what happened? Your density is higher. So density is higher. You can say your polar region is, or the tropopause you can find at 10 kilometer of the height, 8 to 10 kilometers of the height. Okay, so it will vary depending on season as well, because it's switching like this. Entire layer is moving. Okay, if you see that layer, this layer is coming and going up and higher and down based on the season it is. So it's not constant thing, but to remember that, you have to remember this thing, that uh, you have to just remember that your tropopause is for 8 to 10 kilometer on polar region. Okay, and at equator region it is approximately 16 to 18 kilometer. Okay, so you can basically get 16 to 80 kilometer of tropopause. Okay, and up to the tropopause, what will happen? What is tropopause? Basically, you can say that tropopause is the end of your thermosphere. Sorry, correction. Troposphere. Your end of troposphere will be subjected to your, at the end of the uh, this thing, end of the troposphere, you will find tropopause. Okay. Up to tropopause, there is a drop of temperature, say roughly minus 56.5 degree. After that, the temperature will start to have a constant value in the tropopause region, and after that, it will increase. Okay. So tropopause is the lowest portion of the sorry, correction, the troposphere. The troposphere is the lowest portion of the atmosphere. So troposphere can be called as lowest portion of the atmosphere. Okay, and it is derived from a Greek word. Tropos means turning, as your earth is turning, and sphere means earth. Okay, so from the Greek word it is derived as troposphere. Tropos means turning, and sphere means earth. Okay, and this troposphere is having a homogeneous mixture, as we were discussing earlier, because of turbulent mixing. Okay, and this turbulent mixing is also causing the weather. So you can say that your turbulent mixing is responsible for occurrence of weather. Okay, we already discussed at equator, uh, you can expect your tropopause, or you can say the end of troposphere is approximately at equator is 16 to 18 kilometer, and at the pole it is 8 to 10 kilometer. Okay, and temperature is falling with the height, as we were discussing earlier. This phenomena is known as lapse rate. Always remember, because it will be continuously repeating in the future chapter as well, lapse rate. So the phenomena at which, as the height is increasing and the temperature is falling, okay, this is called as lapse rate, and it is predefined in ISA condition. We assume it to be 6.5 degree per kilometer or 2 degrees Celsius per 1000 feet. Okay, so every time you're going 1 kilometer higher, 6.5 degrees Celsius temperature is 6.5 degrees Celsius temperature is reducing. Or 1.98 degrees Celsius per 1000 feet. So we roughly take it as 2 degrees Celsius for easier of our calculation. So these are the both same thing. Okay. For more accurate, if you want, you can take 1.98 degrees Celsius, and uh, for easiest purpose, we just take 2 degrees Celsius. Okay. Now we got one more phenomena. Yes, this is called as lapse rate. Okay, I'll just write the lapse rate. So temperature, I'll write in a blue. So temperature falling with height is called as lapse rate. Okay, that phenomena is around 6.5 degrees Celsius per kilometer. Okay, already written that. We won't write that again. And if the temperature is increasing instead of decreasing, that phenomena is called inversion. Basically, what it is supposed to have, it's supposed to have fall the temperature, but now inverse thing is happening, that increasing temperature. This phenomena is known as inversion. Okay, so what is inversion? The temperature rising with increase, height increased. Okay, and if inversion take place, your troposphere is unstable, because ideally it should have decreasing temperature. Now it is increasing temperature, so troposphere became unstable. The next thing is that troposphere is also further subdivided. How that subdivision is take place? Say example, they have divided in lower, mid, and upper tropopauses. Troposphere. Okay. So surface to 2.1 kilometer, we assume it as lower troposphere. 2.1 kilometer to 7.6 kilometer, we assume as mid troposphere, and beyond that, up to tropopause, we assume it to be upper troposphere. Okay, from 7.6 kilometer to tropopause. Then we got some characteristic called as fold. Okay, so what is fold basically? Okay, in this diagram, I'll show you. You can see there are certain bending. It's not smooth. This bending occurs at particular angle at 40 and 60 degree. This is due to the change of atmosphere. In the upcoming chapter, we will study that. This will cause that sudden drop and change in this thing, and this is called as break or fold. Okay. And one more key parameter to remember, that just below your tropospheres, just below your tropopause, there is presence of jet stream, and temperature is around 80 degrees Celsius at equator around troposphere, and at polar region it is minus 50 degrees Celsius. Okay, at polar tropopause you'll say the temperature is minus 50 degrees Celsius, and at equator it is minus 80 degrees Celsius. Remember that. Why? Because the height is high. Okay, height is very much at the equator. At polar region it is low, so that's why temperature difference takes place. Okay, so up to 8 kilometer of height, your temperature reversal take place. Up to that, polar region is colder. After 8 kilometer of height, the reverse phenomena take place. Okay, so this thing is called as, remember, break or fold. This is called as break or fold. Okay, and there is a reversal of temperature and density above 8 kilometer. Okay. We got few more tropopauses variation: polar tropopause, middle tropopause, and tropical tropopause. Middle tropopause and tropical tropopause. Okay, so it is 300 hectopascal, 200 hectopascal, and 100 hectopascal. Okay, and the presence of your polar tropopause is around latitude 45 degree to 60 degree, and middle tropopause you can find around 23 degree north, about 11.5 kilometer of height, and tropical tropopause you can find at 35 degree to 40 degree north, at around 16 to 16.5 kilometer of height. Okay, the last point of this topic is ISA. Okay, what is ISA stand for? ISA stand for International Standard Atmosphere. Now what happened? Your instruments of your aircraft has to be designed for a particular type of atmosphere. Even though the atmosphere is not constant, it is continuously changing, but they have to be keep a certain standard so that they can even eventually manufacture all across the globe. Okay, so ISA is established by ICOM. Okay, so it is issued by ICOM. Its full form is International Standard Atmosphere. One of the famous favorite questions of DGC is ISA. So a lot of time they will ask uh, one of the parameter. Okay. Before that, I'll show one more of image to you guys. Look at this image. Look at this image. So this is also again troposphere, tropopause, stratosphere, mesosphere, thermosphere. Okay, you got stratopause, mesopause. So at the end of each layer, you got pauses, and up to this point, okay, at as you're doing in a troposphere, what happened? Your temperature is decreasing. Okay, up to what? Decreasing up to minus 56.5 average. Okay, and beyond this point, it is constant. Okay, after that it start again increasing, then it was constant. In mesosphere again start decreasing. Okay, again constant, and finally it start increasing. So okay, this is one thing. And talking about ISA got different characteristics. First thing is defined by ISA is that air is dry. Okay, second thing, the temperature. The temperature they have defined at MSL. What is MSL? MSL is that mean sea level. Okay, it's all the parameter are according to MSL. MSL stand for mean sea level. What is mean by mean sea level? Mean sea level, because the sea level is throughout the earth is different, so they have taken a mean of all the sea level and it is assumed to be the lowest one, even though there are lowest region present below MSL, but it is assumed to be standard. Okay. The temperature is assumed to be 15 degrees Celsius. Okay. In Kelvin, it will comes to be 288.15 Kelvin. Okay. The pressure is assumed to be 1013.25 hectopascal. So this is the pressure. The next parameter is density. So density is measured in gram per meter cube. Okay, and it is given as 1225 gram per meter cube. Okay, and the last point is acceleration due to gravity. Is given as 980.65 centimeter per second square. Okay, now talking about your lapse rate. Your lapse rate is given as 6.5 degrees Celsius per kilometer. Okay, it will comes to be approximately 1.98 degrees Celsius per 1000 feet. So this is the basic conversion. Okay, this is up to roughly at the tropopause or 10 kilometer of the height. So 11 to 20 kilometer of height, we have seen that this is a constant phenomenon. So what is the constant temperature in this region? In this region, the constant temperature is about minus 56.5 degrees Celsius. Okay, so constant temperature of minus 56.5 degree Celsius from 20 to 30 kilometer, the temperature again start rising. At what rate? This increasing by 1 degree Celsius per kilometer. So rise in temperature 1 degree Celsius per kilometer. Okay, and at approximately 32 kilometer of height, the temperature is around 44.5 degrees Celsius. Okay, so up to 32 kilometer, we are expecting. We got, this is your international standard atmosphere. We got one more standard, that is JSA. Okay, what is JSA? JSA stand for Jet Standard Atmosphere. What is jet atmosphere? Jet standard atmosphere. It is beyond 30,000 feet of height. Beyond 30,000 feet of height, the most of the jetliners fly. Okay, all the commercial aircraft that is flying from 29,000 to 41,000. So it is applicable for beyond 30,000. So what they have, and assume it is approximately almost the same thing. Just they have assumed one more criteria, that MSL temperature is same. MSL temperature is 15 degrees Celsius. Lapse rate is 2 degree Celsius per 1000 feet, and there is no tropopause. Topic of this thing we have to consider is ISA deviation. This is a numerical based question, a lot of time asked in an examination. What is ISA deviation? So we have defined the temperature that at the mean sea level it is 15 degrees Celsius. Okay, this is 15 degrees Celsius at mean sea level. Say assume this is the mean sea level. As you're going higher and higher, what will happen? This temperature will fall. By what rate? Say 2 degrees Celsius per 1000 feet. That is that is your standard lapse rate, right? Say you climb 1000 feet. So what temperature will be there? 15 minus 2, you got 13 degrees Celsius. Again you climb 1000 feet. What temperature will be there? 11 degrees Celsius. Again you climb 1000 feet. What temperature will be there? 9 degrees Celsius, and so on. Okay. Now assume what is a ISA deviation. This is according to ISA. Okay, this is gone to standard atmosphere, but in reality it could vary. So what is ISA deviation? So ISA deviation can be defined as actual minus ISA. Okay, say for example, this is 3000 feet of height. Okay, after 3000 feet of height, in reality, you find the temperature to be 10 degrees Celsius. Okay, you find the temperature to be 10 degrees Celsius. But according to ISA, how much should be the temperature will be 9 degree. So how much is the deviation? 1 degree. Okay. So this is the basic formula of ISA deviation. You can calculate. A lot of numerical comes on this. Not lot of you, because in aviation meteorology you get 50 questions and 1 or 2 questions might come from this atmosphere chapter. That will be killer deal, easy scoring marks. Okay. So you get the idea how you can calculate. So whatever the height you have to calculate for 2 degrees Celsius, you have to do the calculation and you get your ISA temperature. So ISA temperature at 3000 feet is 9 degrees Celsius. And if the actual temperature is given in the question, you can subtract both and you get the answer. Hopefully today's lecture you understand everything. If you have any doubt, you can comment in or you can ask me in chat. Okay, you can contact me. Try to join Gorilla classes. Okay, we got our app. You get the entire course at very affordable rate. You can check it out. Okay, and the promotion, just go throughout our app. If you have any doubt, you can reach out to us. Thank you.